everyone, this is Abby, the recitation instructor for session number 9. I just wanted to go over the last few problems in the recitation 1 worksheet. It seems like there was generally a little bit of confusion, so I just want to make sure that everyone's on the same page with the understanding. So we're going to start with problem number 10, which gives you the values for a bunch of variables, and it's asking you to solve for P1. And so we isolated P1 in an earlier problem, so I'm just going to write that here. P1 is equal to P2 times V2 times T1 over V1 times T2. And so what we have to do here is basically just plug in all of the variables, but I do want you to pay attention to the ratios that we have here and make sure that the numerator and denominator match what's in the equation. So we can start by plugging in P2, which we have the value for. And then we come to this V2 over V1 variable. But you'll notice that in the problem, we're given the opposite fraction. We are V1 over V2. And so if you'll remember from your lecture videos, if you want to invert a fraction, all you have to do is take the negative exponent. So we can actually take the negative exponent of this value, 3.05, to the negative first, and then we multiply by T1 over T2, because that's exactly how it appears in our equation. So we don't have to flip that one. And so then all that's left is to plug it into your calculator. It might be a little bit weird plugging in a negative exponent to your calculator, so we can actually rewrite this as the value of P2 times the value of T1 over T2. And then we can just put this number on the bottom, because that's what the inverse exponent means. And so when you plug this into your calculator, you should get 1.95 times 10 to the 6th. And don't forget your units. And so that's a good way to solve number 10. Now for number 11, we're asked which of the following equations is correct with respect to equation C above. And so what you'll notice in both of these options is that lambda is by itself as the numerator, but in equation C, it's actually on the bottom of the fraction. And so just like in problem number 10, if we want to flip a fraction, we take the negative exponent of it. But what we do to one side of the equation, we always want to do to the other. So we can actually take the negative exponent of this whole thing. And when we do that, we get lambda, because we're flipping that fraction, over RH, in parentheses, 1 over and 1 squared, minus 1 over and 2 squared, all of that to the negative 1. And then that looks exactly like this second equation. So now for number 12, it wants us to isolate the value RH from equation C. So we're just going to write equation C again. And what we have is RH multiplied by this big parentheses. And to get RH alone, we want to divide both sides by everything in the parentheses. That would also be the same as multiplying it by the inverse of everything in here. So that's what we're going to do just for space. So we're going to multiply everything by everything in the parentheses to the negative first power. And so on the left side, we would have 1 over lambda and all of that to the negative first power times RH. And so technically we're done here, but we want this equation to be in the most compact form. And to do that, we can actually look at this lambda term, and 1 over lambda is the same thing as writing lambda to the minus 1 power. And since both of these would have the same exponent, then we can pull out the negative exponent and write lambda times the whole parentheses again to the negative first power. And that's just a little bit easier way of writing everything on the left side. And that is all equal to RH. So that would be your answer for number 12. And you don't technically have to do this distributing to the negative power. You could just leave it as this equation right here, and that would still be correct. So now for number 13, we want to isolate N2 from equation C. So we're just going to write equation C again. And so this is the variable that we're trying to isolate. So we have a few things going on here. We have the whole parentheses multiplied by RH, and then we also have everything going on in between the parentheses. So we have a little bit of subtraction here. So the first thing that we want to do is deal with everything outside of the parentheses. And so that's this RH term. And to do that, we can just multiply everything by 1 over RH, which would cancel out the RH on the right side of this equation. And that would give us 1 over lambda times RH is equal to 1 over N1 squared minus 1 over N2 squared. And so we're still trying to isolate N2 here, so we can actually subtract 1 over N1 squared from both sides of the equation. And that would give us 1 over lambda RH minus 1 over N1 squared is equal to minus 1 over N2 squared. And so it gets a little bit tricky right now because we have not only a negative sign in front of our fraction, but we also have N2 squared on the bottom of our fraction. So we're going to deal with both of those at the same time. So to get rid of the negative sign, we're just going to multiply everything by -1, because -1 times -1 is equal to +1. And then since we want to get N2 squared on the top of our fraction, we're also going to take the minus exponent. And so that gives us minus 1 over lambda RH plus, because we're going to distribute the negative sign to both of the pieces on the left side. And all of this is to the -1 exponent, and then we have N2 squared here. And so we're really close. We have N2 isolated by itself, but it's still squared here. So what we're going to do is take the square root of both sides of this equation. And that gives us N2 is equal to big square root minus lambda times RH plus 1 over N1 squared. That's all still to the -1 power, and then we close the square root. So that would be the answer to number 13. Now for number 14, we want to find the value of N2. So we can use this equation that we just solved for N2, and we'll just write that again. And now we can just plug in all of the values that were given in this problem. So we have N2 is equal to big square root, lambda is equal to 4.85 times 10 to the minus 7 meters multiplied by RH, which is 1.10 times 10 to the 7th meters inverse, plus 1 over n1, which is 2, and that's squared. Everything is still to the minus 1 power, and then we close the square root. So then we can just start plugging these things into our calculator. And one thing that I want to note is this m minus 1 value, and that is the same thing as writing 1 over m. And so when we have m times 1 over m, our units actually cancel out. So this denominator here will actually be unitless. So we have n squared, big square root, and then this number should be 1 over 5.335 plus 1 over 4 from this last part. All of this is still to the minus 1 power, and then we close the square root. And so then to continue plugging this into our calculator, we would get n2 is equal to the square root of 15.985. And when you plug that into your calculator, you get 3.998. And since the original problem says we want our answer in a single digit positive integer, we can round this to 4. And that would be your answer to number 14. So hopefully that helps everyone. Feel free to come to office hours if you wanted to go through this in a little bit more detail.